In this example, we're going to evaluate this definite integral. We're going to go from 2 to e plus 1, and the integrand here is this rational expression. If you would like to try it first, go ahead and pause the video and do so, and then come on back and we'll work it together. All right, looking at this integrand, we have x over and then x minus 1, and that little expression there is being squared. This seems like this will be a good candidate for a change of variables, specifically a U-substitution. So we're going to take this little x minus 1 critter that's in here, and we're going to say u equals that x minus 1. So when we differentiate both sides, we'll have du equals dx. But of course, whenever we are doing a change of variables with a definite integral, we also need to change our limits of integration from being in terms of x to change them to being in terms of u. So let's go ahead and do that. So we started with x, and that first one was a 2, and then we started with an e plus 1 was where that upper limit was. So now when we plug them in, we're going to take x minus 1, and that equals our u. So our u will be this x value, which is 2, minus 1. So our lower limit now will be 1 instead of 2. And our upper limit will be this e plus 1 minus 1. So those 1's cancel, so it looks like we just have e. So let's go ahead and rewrite our integral now. And so we have the integral from, so instead of being from 2, we're going from 1. And instead of going up to e plus 1, we're just going to go up to e. And now, our rational expression here, we have this x in the numerator that we'll have to deal with, but we had x minus 1, which was our u, so u squared, and our dx just changed to du. All right, well, everything is in terms of u now, with the exception of this x up here. So what we're going to do is go back to our original U-substitution definition and go ahead and solve for x right here by adding 1 to both sides. So it looks like x will equal u plus 1. So let's go ahead and make that substitution. So I'll have the integral from 1 to e of, and then our x, remember, is going to be u plus 1. So u plus 1 over u squared du. So now everything has been changed, and it's all in terms of u. And let's go ahead and take this fraction and break him up a little bit. So it'll be the integral from 1 to e of, and we have u over u squared plus 1 over u squared du. And we can simplify some things a little bit here, and maybe rewrite this with a negative exponent so it'll be easier to integrate. So the integral from 1 to e of, and this u over u squared will just become 1 over u, and then plus u to the negative 2 power. All right, so we are now ready to integrate. Okay, well, the integral of 1 over u is just going to be the natural log of the absolute value of u. And then the integral of u to the power of negative 2, well, we're going to add 1 to this power, so we'll have negative 1, and then divide by that new power, so dividing by negative 1. So dividing by a negative 1, basically we'll just change this positive to a negative, and then our power now will be u to the negative 1, which I can just rewrite that as 1 over u. And we're going to evaluate that from 1 to e. So let's go ahead and do so. So plugging in the e first, it looks like we'll have the ln of e minus 1 over e. And then minus, and then we'll plug in the 1, so the ln of 1 minus 1 over 1. Well, the natural log of e is just 1, so 1 over e, we're subtracting here, so 1 minus 1 over e. The natural log of 1 is 0, and then so we're subtracting a negative 1, so we're really going to add 1 there. So finally, 1 plus 1 is 2 minus 1 over e. So that didn't come out too badly at all. So here is the expression then for the definite integral. So 2 minus 1 over e. And that original integral up here was right here. So the integral from 2 to e plus 1 of x over x minus 1 quantity squared with respect to x. We did a quick change of variables, ensuring that we also changed our limits of integration as well. And when we were done, we saw it evaluated at 2 minus 1 over e.